Guys, here's another interesting math challenge that we'll be solving today. From the question given to us, we have e to the power of x plus e to the power of x, and this equals e to the power of e. From here, we can see that they have the exact same base, so we can say e cancels e, and then we'll be left with x plus e to the power of x equals e. And then we can rearrange both sides of our equation and have e minus x. Then after doing this, we are going to be dividing both sides of our equation by e to the power of x so that we can achieve a very interesting pattern that will be useful for us in the course of this video. So this cancels this and we're left with 1 equals e minus x divided by e to the power of x. And from here now we can apply an interesting law of indices right here. We can just say 1 equals e minus x multiplied by e to the power of minus x. And that's according to the law of indices because we can convert a denominator to a negative power. Moving further here, we are going to multiply both sides of our equation by e to the power of e. And also here we're going to have e minus x times e to the power of minus x. Also here too, we're going to be multiplying by e to the power of e. And after doing this, we're going to be using the law of indices to simplify this. Here we'll be left with e to the power of e, and that equals e minus x multiplied by, according to the law of indices, since they have the same base, we are going to be adding these two power together, and it will give us minus x plus e. But instead of us writing minus x plus e, we are going to be writing e to the power of e minus x because they are the same thing. Then let us include a bracket. Now looking at this, we can apply the Lambert W function. When we take the W function of this equation, and don't forget that from the property of the W function, we are going to solve this very easily. W function tells us that when you have m e to the power of m equals a constant, which is a number, and when you take the W function of both sides, then m is going to be the value of the W function of that constant. And in our case here, m stands for e minus x, and the constant or the number in this case stands for e to the power of e. And then following this property, we are going to discover that e minus x would be equal to the W function of e to the power of e. And from here now we can solve for x. Then by rearranging and transposition, we'll find out that x will be equal e minus W function of e to the power of e. And then when we use the Wolfram-Hafer to evaluate this, or any scientific calculator of your choice, you'll find out that x will be approximately equal 0.7015. And this is our final answer. Guys, if you love this solution, don't forget to subscribe and do have a good day.